Hello, hello, my dear friend. A very warm welcome to all of you. Today we are going to discuss sampling technique and all the question which can come from that topic. So this is a very simple topic actually if you understand the basics. The first thing is what is random and non-random sampling. Random means कोई भी आ सकता है, anyone can come, everyone has equal chance of selection, that is random sampling. But in the random there are actually 6 type of sampling. First is simple random. Suppose I have to choose any 10 students out of your class of 100 and I want to know how many movies you watch in a week. I want to do a study on that topic. So I can take your names from the management and I can put that name in the computer. There is a software also, SPSS software, and I will ask the computer that give me any 10 name out of 100 randomly. So computer will give me 10 name out of 100 by using lottery method, which is in the software of some of the app. So just randomly, or if it is a live class, I can ask one person to choose out of 100 chit. So this is lottery method, and this is best when we are doing the sampling for homogeneous population. See, homogeneous means who are equal to each other. Like in watching movies, it doesn't matter whether you are sitting in front row or back row. Anyone of the batch can be taken to know this thing that how many movie you watch in a week. है कि नहीं? एक हफ्ते मूवी के मामले में आप सब बराबर हो. लड़का चुनूं लड़की चुनूं कोई फर्क नहीं पड़ता है. Whether choosing boy or girl doesn't matter. For movies, everyone watch it, so I can directly take the sample randomly. But suppose I want to take 10 people for a party, and in that party I want that there should be some love making between the boys and girls which go. Because I hope you know I am happily married, settled type of person with 2 kids and all. But I want there to be more love among people, among students also. So I have to choose 5 boy, 5 girl out of 100. If I ask you to choose by lottery method, then there is a chance that out of 10, 8 can be boys, or out of 10, 9 girls can come out. I want 5 boy, 5 girls so that they can also have setting. So I will first divide you among boys and girls. Let's say there is 40 girls and 60 boys in the class. I will divide them. And then after dividing, I will ask them randomly to choose 5 chit out of them. So in this way, I am dividing you and then choosing. This is a stratified random sampling. Because stratified word means layer, you know. Creating layer, creating division, strata. Strata मतलब अलग अलग स्तर के लोग है ना, different strata. So I am creating this strata when you are heterogeneous. This is best for heterogeneous population. What is heterogeneous? Heterogeneous means who are different from each other. For example, when it comes to sex, some of you are boy, some of you are girl. So based on sex, I can divide you. Based on religion, I can divide you. Based on your gender, gender already discussed. Based on your which prof you belong, I can divide you. So do remember this point that in any question, if they are dividing based on anything, suppose based on race you are dividing people, based on religion you are dividing people, based on diet you are dividing people, because diet can differ according to religion or according to places. Based on gender, like male female, you are dividing people. So this is a very common question coming these days in the exam. 2 questions came from this topic in last year NEET also, that when they took some people, divide them and then choose equal which type of sampling it is. So that will be stratified random sampling. Like let me give you a very common example. They ask this question that diet of people depend on religion, have some effect of religion. So if you want to know the effect of religion on diet, you have decided to choose, let's say 50 people from different 3-4 different religion, Hinduism, Islam, Christianity, 50. So if you are dividing people based on religion and diet, which sampling you are doing? So that is a stratified random sampling, because people were living together, all are human. You created the layer, you divided them into religion, because human divided them into religion. So if we divide them into religion, or the researcher divide them into religion, we call it a stratified random sampling. That's why I am writing that it is best for heterogeneous, which are different from each other. And if they are homogeneous, simple random sampling by lottery method is best. So this is heterogeneous, the population which is different from each other as per the question. सवाल के हिसाब से अलग होने चाहिए. जैसे मेरा सवाल था लड़के लड़की को ले जाना है ना. My question was to bring boys and girls 5-5. So based on the question you were different. If the question is suppose of marks, then you are homogeneous. It doesn't matter whether you are boy or girl. If the question is of, let's say, movie, how many movie you watch in a week, then you are homogeneous. It doesn't matter whether you are boy or girl. So if the question is heterogeneous, then we do stratified random sampling. One very good example which you can have is that suppose you want to know in which state of India people smoke more. A medical college student smoke more, in Aligarh, in Delhi or Jaipur. So if you want to know about it and you thought to choose 10 students from Aligarh, and suppose out of 10, 8 came boy, then it will come that smoking is very high in Aligarh. But if out of 10, suppose 7 or 9 came girls, then it will come that smoking is very less in Aligarh. Because when I was doing my MBBS there, at that time, girls used to smoke less as compared to boys. I don't know about present time. So if it comes to smoking, in some states of India, not everywhere, boys smoke more than girls. And if boys are smoking more than girls, and we want to compare 2-3 city, then we should choose 5 boy, 5 girls, 5 boy, 5 girls from different city. Because if you choose them randomly, then out of 10, 8 or 9 can be boy or girl, and the data will not be comparable between different city. Suppose in Aligarh 9 girls came, in Delhi 9 boys came out of 10 sample. So then smoking will come very less in Aligarh, very high in Delhi. But it might not be the real picture. To know the real picture, we have to divide them first, then choose equal number from both the group. So this is stratified random sampling. Now let's understand a very simple thing now. I have to choose 10 people out of 100 people for a party. Rather than dividing you into boys and girls, I just say, give me any random number between 1 to 10. And suppose there is in the class, there is population of 100 people and I want to choose 10 out of 100. So if I want to choose 10 out of 100, 10 by 100 is 10. Then I will ask you, give me any random number between 1 to 10. Suppose you gave the random number 7. So what I will do is I will start from one side, 1, 2, 3, 4, 5, 6, 7. And every 7th student I will choose for the party. 7, then 8, 9, 10. Then again I will start 1, 2, 3, 4, 5, 6, 7, 8. So 7 again I will choose. So like that I am choosing every 7th participant. This can be 7th, 8th, 9th, any number between 1 to 10. How I got 10? When I divided population with sample size. In my example, there were 100 students and I need to take 10 people. So 100 by 10 came 10. I ask you to give a random number between 1 to 10. And if I am choosing nth number, that is systematic random sampling. Let's take a very good example. This is there. If every number is 7, then let's take a very good example of it. They ask this question. Suppose you want to do a study to know whether villagers are using condom or not. What do you think? Villagers use condom or not? Hey, how come you know? You have not checked what is below their lungi. You want to know it. So if you want to know it, you thought that I will do interview of every first and fourth house. So every first and fourth house you will go in the village and you will interview them to know whether they are using family planning method or not. Okay. Every first and fourth house interview for use of condom questionnaire. Simple. So if I am choosing every 7th, every first, fourth, this is all I am following a system. And how come that first and fourth came? It came random. So it is systematic random. Simple. Now the fourth is cluster random. Cluster is a group of people with common origin, whose origin must be common. For example, people living in Bihar or coming from Bihar have one cluster, one origin. People living in, let's say, Jammu Kashmir are common from their origin, Jammu Kashmir. So if I am doing a study in which I want to know that how many breastfeeding, exclusive breastfeeding percentage of children are exclusively breastfeed in different parts of India, I want to do a study. So I can go and interview 30 mothers from Jammu and Kashmir, 30 mothers from Bihar, and this 30 people I have chosen from different states. So these 30 are cluster because all these 30 were common origin. So I will go to Jammu and Kashmir, choose 30 people, go to Bihar, choose 30 people, and I will compare the data between these two states. So this is simple example of cluster random. And one of the very good example is the WHO immunization study, which is done on vaccination. This is actually the way how WHO try to know that what is percentage of immunization in different states. Like for example, if I ask you, in which state immunization is lower, in Bihar or in Uganda, which area? So I don't know why, but every time I ask this question, people point my finger towards me and say ki Uganda, they tell it to me. So suppose you want to know, you don't know who is less immunized, Bihar or Uganda. So what you have to do according to WHO immunization trial, you will choose 7 children between 12 to 23 months. You will choose the 7 children from Bihar, 30 villages, and 30 villages of Uganda also. So you are choosing 7 children from 30 villages. All these 7 children are coming from the same village. So all these 7 children are cluster because they have common origin of the village. So you are choosing 7 children from 30 villages. So 7 into 30, total sample size is 210. You will go and interview those 210 mothers who are randomly chosen from 7 group, 30 children, their mother you will interview. And suppose in Bihar it came that out of 210, 150 are immunized. And in Uganda, suppose it came to know that only 100 are immunized. So that means who will have lower immunization? Yes, Uganda. Uganda will have, and Uganda is a real name, and I have not created it. Okay, so you understand the point. We choose people from different cluster, interview them, and then we can compare them, like here in WHO immunization study. But there is one more thing we have to understand, that whenever we choose cluster, this cluster are people with common origins, so they have less variation. मैं कहना क्या चाह रहा हूं कि जब हम क्लस्टर लेते हैं तो लोग एक गांव से हैं, एक कॉमन ऑरिजिन से हैं, तो उनमें एक जैसे गुण पाए जाएंगे. जैसे हो सकता है कि सातों के सातों बच्चे इम्यूनाइज्ड हो क्योंकि एक गांव में इम्यूनाइजेशन अच्छा हुआ हो, और दूसरे गांव में जाओ तो सातों के सातों नॉन इम्यूनाइज्ड मिल जाए, तो उनमें वेरिएशन कम होता है, यानी उनके डेटा एक जैसे होते हैं. तो क्योंकि उनके डेटा एक जैसे होते हैं, इसलिए हमें ज्यादा लोगों को स्टडी में इंक्लूड करना पड़ता है. जैसे हमने क्लस्टर रैंडम सैंपलिंग से इम्यूनाइजेशन ट्रायल निकाला, उसका सैंपल साइज निकला 210. अगर यही हम सिंपल रैंडम से करते तो 150 से काम हो जाता या 140 से काम हो जाता. तो यही मैं कहना चाह रहा हूं कि क्लस्टर रैंडम सैंपलिंग के लिए जो मैंने सैंपल साइज लिया 210, ये 2 बातों पे डिपेंड करता है. एक तो डिजाइन इफेक्ट क्या है, और दूसरा सिंपल रैंडम सैंपलिंग का सैंपल साइज क्या है. तो मान लो सिंपल रैंडम सैंपलिंग का सैंपल साइज आया 140, क्योंकि सिंपल रैंडम सैंपलिंग में लोग बिल्कुल अलग अलग होते हैं एक दूसरे से, तो उसमें कम लोगों में भी हमें ज्यादा वेरिएशन मिल जाता है, ज्यादा अलग अलग डेटा मिल जाता है. इसलिए सिंपल रैंडम का सैंपल साइज कम होगा, क्लस्टर रैंडम का सैंपल साइज हमेशा ज्यादा होगा, और इसी को कहते हैं डिजाइन इफेक्ट. तो अगर आप देखो तो डिजाइन इफेक्ट में हम लिख सकते हैं कि क्लस्टर का सैंपल साइज डिवाइडेड बाय सिंपल रैंडम का क्लस्टर साइज. जैसे यहां पे क्लस्टर का रैंडम साइज था, सैंपल साइज था 210, सिंपल का 140, तो 210 बाई 140 करोगे तो आएगा 3/2, और 3/2 का मतलब 1.5. डिजाइन इफेक्ट हो गया 1.5. ओके, समझ में आ रहा है बात को. क्लस्टर में कम वेरिएशन है तो इसलिए ज्यादा लोगों को लेना पड़ेगा 210, सिंपल रैंडम में कम से काम चल जाएगा, इसी को कहते हैं डिजाइन इफेक्ट. सो व्हाट आई वाज सेइंग इन इंग्लिश वाज, इन हिंदी वाज दैट whenever you choose cluster, they are mostly similar to each other, they have less variation. For example, when you choose 7 children from 30 villages, maybe that all 7 children are immunized, or maybe that all 7 are non-immunized because of the village condition. So in cluster, people are similar. That's why we need to take higher number of people in cluster random sampling. Like in the WHO study, we were doing cluster random sampling in 210. If we have done the same study by choosing children randomly from India, then even by 140 the study could be done. Because when we are choosing them randomly, their data is more different from each other. They have more variation. So sample size of cluster random is always more than sample size of simple random sampling. By how much it is greater? It is greater than design effect. What is design effect? It is simply sample size of cluster is design effect into sample size of random. So when in this question we want to try to find, we are trying to find the design effect. Design effect means cluster sample size by simple random sample size. Cluster random size was 210, simple random was 140. So design effect came 1.5. Design effect is never less than 1. It is always more than 1, because in cluster random sampling we need to take more people because they have less variation, and in simple random sampling less people is needed because they have more variation. So always remember, cluster random sampling is having greater sample size than simple random sampling. Chalo. So I think this part is clear. Cluster random sampling, 4 type of sampling we have done. We will revise them also. What is multi-stage random sampling? Suppose you want to know that what is the smoking prevalence of children in class 11th and 12th in Delhi. And which smoking you want to know, cigarette or marijuana? I don't know why, but in every class I give the option. Students say, sir, let's know about marijuana prevalence smoking. So suppose you want to know that how many students in 11th, 12th class in Delhi are smoking marijuana. Okay. You want to do a study on that. So in multi-stage, what we do is, first you take some map of Delhi and you draw any amoeba like thing, it will become Delhi, because Delhi is going in every state. And so this is Delhi map, suppose. Okay. And from the Delhi, you can choose any 3 area. In each of these areas, suppose you choose 4 colonies. In each of the colonies, you choose 2 schools. And from each of the schools, you choose 40 children, 20 from 11th class and 20 from 12th class. So how many sample size you have chosen? You had chosen 40 student from 2 school, from 4 colony, from 3 area. So how much will come? 2 into 4, 8 into 3, 8 into 3 is 24. And 24 into 40, 24 into 10 is 240. So 24 into 40 is 800 and 160, 960. So the sample size become 960 if you multiply 40 with 2, with 4, with 3. It is not so difficult. 40 into 2 is 80. 80 into 4 is 320. 320 into 3 is 960. So this 960 children, you will go and you will ask कि क्या तुम गांजा फूकते हो, है ना? Do you smoke marijuana or not? So suppose out of this 960, you got that 10% student, 96 student or 10% student smoke marijuana. So your data came 10% is the prevalence. Now what you will say that in the whole Delhi, the prevalence of smoking marijuana is 10%. 10% student smoke marijuana in 11th and 12th class in Delhi. So is it a good thing to do? Because I did a study on only 960 students and I said this 10% is the smoking prevalence in the whole Delhi. So is it correct to collect data from this small 960 people and tell it to the whole, apply the data on the whole population of Delhi? Is it correct? It's correct or not? This is the only method available. And if I have to ask it from every child of Delhi who is studying in 11th, 12th class, I need to smoke marijuana myself. It will be a never-ending study. You can never ask it on all the population. That is why in US, UK or any other country, whenever they do any study, they always do it by multi-stage random sampling. Let me give you one more example. In UK, every 2-3 years, they do this study that how many sexual partner you have lifelong. And usual answer which come is 2 to 7. But some of the hunter in those areas, they say we have 699 sexual partner, 494. So we have to remove those hunters data, extreme data, by calling them outliers. But average come 2 to 7. So how they have done that study? Did they ask it from everyone in the UK? No. They took some area, then asked from those area, they choose some colony, some spaces, and they went there and interviewed some thousand of people, and they say this is the data for the whole UK. So in every country, whenever you want to collect the national level data, you do multi-stage random sampling. And multi-stage is also known as multiple cluster. Why we call it multiple cluster? Because Delhi is a cluster, out of which I am choosing area, that is a cluster. Colony is a cluster, school is a cluster. So I am choosing cluster again and again. That's why it is multiple cluster sampling. Okay. And now you may ask, sir, why are you drawing the map of Delhi? You could have just written Delhi. Because in exam, when they give question from this topic, they give you a big map of city or US or some area, and then they will choose a small, and they will do the interview of house and apply it on the whole Delhi, on the whole area. So they will ask which sampling is there. That image-based question, I think you can easily do. If map is given a small taken, that is multi-stage. And why I choose Delhi for the map? Because one time I did this mistake of trying to draw a map of Gujarat. And when I was trying to draw the map of Gujarat, some of the students asked, sir, hey, what are you drawing? I said, I'm trying to draw Gujarat. And I was doing mistake there in the map, and they got emotional. But no one get emotional when I draw a wrong map of Delhi. Draw anything, they are like, okay, cool. Delhi is not even ours. And we also migrated here. So no one take it seriously. That's the best thing about Delhi. They feel you that you are welcome here, and no one is from outside. Everyone is from Delhi. So that is there. Now, in NFHS and DLHS, this is two survey which is done national wide, National Family Health Survey and District Level Health Survey. In both of these survey, we use multi-stage random sampling. And this NFHS, DLHS, they give data on 5 things. This question has also been asked. Who give data of immunization? So that is National Family Health Survey or District Level Health Survey. They also give data of breastfeeding, domestic violence, anemia, and iodine deficiency. Reported domestic violence is 34% in India. So that is a very troublesome situation for us. We need to work better in upbringing of our children, and this is one concern area. But anyway, try to understand this 5 area of data: domestic violence, immunization, anemia, iodine deficiency, breastfeeding. If they ask come from which study, so these data are coming from National Family Health Survey, NFHS and DLHS. And how are we doing NFHS, DLHS? By multi-stage random sampling, which I just gave the example of. Okay. Now, there is one more method of data collection, that is census. But in census, do remember, there is no sampling. So which study or data collection method have no sampling? Census. That means in census, we ask question from everyone, and this was usually done once in 10 years. But last census has occurred in India in 2011, and we are still waiting for the census. But census is not happening in our country for a very long time. But usually before that, it used to occur every 10 years in month of January, February, March, like when we can collect the data easily. And when census used to occur, I still remember it happened in my house. They come with this 4 or 5 big page of performer, and they ask everything about us, our socioeconomic status, how many boys, how many girls are there, which caste we belong, do we have a bicycle or a car or a motorcycle, do we have a TV or not, fridge or not. So they ask a lot of questions to get any of this data, all of this data. But do remember, census never talk about death. This was one of the INI-CET question which came. Census don't collect death data. Death data is collected by SRS, Sample Registration Survey. And this SRS is the third method of data collection. This has been asked 2-3 times, this question, that which of the following is a double data recording method? That is SRS. Why it is double data recording method? Because first of all, ASA or some field worker, they will come and they will collect the data. Then after 6 months, supervisor will come and they will also collect data. So first ground worker will collect, then supervisor will collect, and then they will cross check whether the data collected was correct or not. And finally, when they release the data, it is double cross checked. So that's why it is double data collection method, SRS. And in SRS, we get data of IMR, MMR, birth rate, death rate, these data come. Okay. From this part, 2-3 question has come. First question is, what is the target of IMR, MMR for India? So the target for IMR, MMR is, target MMR for India is less than 70 per lakh. This is our target also, and this is Sustainable Development Goal target also for 2030. MMR should be less than 70. And what is the target of infant mortality rate? IMR should be less than 30. This is less than 30 per thousand, and I hope you know MMR is less than 70 per lakh. So these two targets are there for MMR, IMR, and who give us the data of IMR, MMR? SRS. And last year MMR was 103, but we don't need to remember the data, they never ask it in the exam. But roughly the MMR of India is around 100, and IMR is now around 25, 28. But it's keep on changing every year. They don't ask the current data, they ask the target. Do remember. So they ask one more question from here, that if you are in rural area, birth rate and death rate data, are they reported at subcenter, PHC, CHC? Where do they report birth rate, death rate? So remember, death rate, death and birth, both of it. These are, where do you register it? Can you give me the answer? Where do you register birth and death? And where do you register marriage? These two questions has came. So let's check it out. Can you guess or tell me the answer? Let me check out the response. Okay. Monish has said, if possible, class in English, sir, don't know Hindi. Yes, bro, I know that depending on our random birth, we can know some language, we can have difficulty in other language. That's why whatever I tell in Hindi, I always repeat the same thing in English. Okay. Because if I would have born in Tamil Nadu, even for me, Hindi could be difficult because in the school system, it is not there. So we are not responsible for our language, our religion, and our caste. So we should be equal, love each other equally. So don't worry for that. So what is the answer for birth rate, death rate? Birth rate, death rate is registered at PHC, and marriages are registered at sub-center. Do remember. And when we register birth and death, the date by which birth and death should be registered is up to 21 days. Within 21 days, if you did not register birth and death, then fine will be applied. They ask this question. And under which registration system, under which reporting system we report birth and death? So do remember this point, that birth and death is registered under civil registration system in India. This civil registration system is from the time of Englishman, and they have birth and death registration. This marriage is reporting at sub-center in village area. In city area, you register it as Office of Sub-Divisional Magistrate, SDM office. I know it by my own personal experience of reporting marriage. And plus, let's say if any one of you want to get court marriage done, it's very simple. You can come on the same day to Delhi or some other state, give some 10,000-15,000 or 20,000 rupees to the lawyer, and they can make your marriage there. But if suppose you are not getting much witness for your marriage, feel free, call me. I will come and help you in your love marriage also, because that's a very good thing, I think, to make two people fall in love to marry and all. I will be the witness, and I may give you the money also if you need at that time, of course, if I have, which will be there. 10,000-15,000, not a big thing. Okay, so use that number whenever you are caught with drug, whenever you run away with someone, and let me know. Okay. So now let's do a very good question on this one topic of census. Census detects sex ratio, and sex ratio means number of female by number of male into 1,000. We always keep female above. Why? In one of the class, I asked a student, said, sir, it make us feel more happy. I said, no, the reason is that only female have the power to give birth to new life. So of course, female should be there above. Plus, when we compare this female by male, multiply by 1000, and if suppose in India, in the last census 2011, they found that the sex ratio is 943. That means we have 943 female for every 1000 male, and because of some female feticide. And this was the adult sex ratio. The child sex ratio was 914. So adult sex ratio was more than child sex ratio. What does it prove? If adult sex ratio is more than child sex ratio, it proves that female feticide is a recent trend. Before, it is the 2011 data, last available data. So adult sex ratio is more, child sex ratio is less. It means gradually we are killing more female. Female feticide is a new thing which occur in last 30 years of Indian history. Okay, that is showing here. Anyway, so let's do a very interesting question on that topic. They said that in a 1 lakh population, if the sex ratio is more than 1000, then which of the following is correct? Female more than 500, male less than 500, female less than 50,000, male less than 50,000. Can you do this question and give me the answer? I will be more than happy to see your response. This is a tricky question. Only people who are Sherlock Holmes lovers and all, they will love such type of question. Okay. Sure. Very good. Gautam Prakash had given one information in the group that under 5 mortality target is 25 and neonatal mortality target is 12. So if you want to remember the target of SDG, Sustainable Development Goal, it's very simple. You just have to remember 3 numbers: 70, 12, 25. 70, 12, 25. 25 is the target for under 5 mortality rate, 12 is the target for neonatal mortality rate, and 70 is the target of MMR. 70, 12, 25. 70, 12, 25. And it's very simple. 25 is under 5. 5 into 5, 25. So 25 under 5. Half of 25 is 12. That is neonatal. And MMR, you have to remember, at any cost 70 is the target. Okay. Chalo. So what is the answer to this question? What is your reply, dear friends? What is the answer to this question? See, if they are saying sex ratio is more than 1000 and they are putting female above, male below. So when will sex ratio be more than 1000? If female by male is coming more than 1, sex ratio will be more than 1000, because if it is more than 1, we multiply by 1000, it will come more than 1000. Let me give you an example. Population is 1 lakh. Suppose we divide the population into half, 50,000 is there. And out of this half population, if female is suppose 60,000, more than half, and male is suppose 40,000, because if female becomes 60, male automatically become 40. And if you do 60 by 40, 60 by 40 come 1.5. So this number of female by male came 1.5. And then we multiply by 1000, 1.5 into 1000 is coming 1500. So it is more than 1000 whenever female is more than half population or whenever male is less than half population. समझाता हूं मैं. देखो मैं क्या कह रहा हूं कि सेक्स रेशियो 1000 से ज्यादा होना है. तो सेक्स रेशियो 1000 से ज्यादा तब हो पाएगा जब फीमेल आधी जनता से ज्यादा हो, मेल आधी जनता से कम हो. तभी हम उसको 1000 से मल्टीप्लाई करेंगे और फाइनल चीज 1000 से ज्यादा आएगा. जैसे अगर आधी जनता 1 लाख का देख लिया जाए तो 50,000 है. अब 50,000 का आधा करो 60,000. 60,000 अगर हम फीमेल बना ले 50,000 से ज्यादा, हाफ पॉपुलेशन से ज्यादा, तो ऑटोमेटिकली मेल 50,000 से कम हो जाएंगे 40,000. और 60 बाई 40 1.5 होगा. 1.5 इंटू 1000 करोगे तो 1500 आएगा, यानी 1000 से ज्यादा आ जाएगा. तो 1000 से ज्यादा आने के लिए या तो फीमेल आधी जनता से ज्यादा होनी चाहिए, चुन लो कोई ऑप्शन में लिखा हो, या तो मेल आधी जनता से कम होना चाहिए, चुन लो किस ऑप्शन में लिखा है, और वही आंसर होगा. What I was saying in Hindi was that sex ratio will be more than 1000 only if female is more than half population, male is less than half. So here the population given is 1 lakh. First step is divide the population into 2 half. Now if the female is coming more than half, like let's say out of 1 lakh female is suppose 60,000 and male is less than half 40,000, then their ratio is 1.5 and 1.5 into 1000 is 1500. So that will come more than 1000. So for more than 1000, which option will be correct? Female less than 50,000 is not correct. Female should be more than 50,000. And we never divide 1000 into half and half. Answer is by dividing, answer we get by dividing total population into 2 half, not 1000 into 2 half. So the correct answer is D, because you can see in the D option, male is less than half population. So male is less than half, let's say suppose 40,000. Female automatically will become 60,000, and final is 60 by 40 into 1000, it will come around 1.5K or 1500. So more than 1000, if they ask, female should be more than half population, male should be less than half. Either of the two condition fulfilled, then sex ratio is more than 1000. I hope this question is clear, but if this question or any question is not clear and you want to ask me the doubt, feel free and WhatsApp me on this number. I will try to answer all your doubt directly. Plus, on the MedEd group, there is this Telegram group. We have this Sankalp batch there. We have the different batches in Telegram group for different group of student. If you message me there on the Telegram group, the answer will come much more quickly, because in the Telegram group, more people are looking. So I have to be more alert there, of course. So do that question. The last sampling is multi-phase sampling. 6th number sampling. I will revise all the sampling which we discussed, but it's a very simple sampling. I met a student who was doing his MBBS from Russia. His name was Dr. Krishna. And Dr. Krishna did a very strange type of study. He asked 10,000 Russian students. 10,000 Russian students he took, which include Indian also studying in Russia. And he asked this 10,000 student that can you touch the middle marking of your little finger with your thumb without making any gap between thumb and little finger. है ना, छोटी उंगली की बीच वाली लाइन को अंगूठे से छू सकते हो क्या बिना गैप के? कैन यू टच the middle line of the small finger with your thumb without making gap? So you can see I can touch it, but when I touch it, there is a gap through which this pen can go. So I cannot touch it actually. है ना? Can you touch it? Let me know in the chat group. So out of 10,000, they found only 47 students can touch it. Can touch, of course, the small finger middle line with thumb. So he asked all these 47 students to go through echocardiography. And finally, 3 out of this 47 came positive for mitral valve prolapse. So, if you can touch your middle line of ring finger with your thumb without gap, it's not a good news actually. If you can touch it, it means your joint is hyperflexible. And hyperflexible joint can also be due to Ehlers-Danlos syndrome. So, and in the Ehlers-Danlos syndrome, your mitral valve can also be hyperflexible, and then mitral valve prolapse can occur. So this type of study is multi-phase. What we are doing is, we are doing multiple cross-sectional study on the same population. First, I ask all the 10,000 students to touch it. This is one population. Then the population which I got, all 47 were asked to go through echo. Then we got 3. So this type of sampling where we take one big population, do the study on the whole population, then whoever pass will come to the next study like that. We are decreasing the sample by doing a study again and again on them. This is multi-phase. And what we are doing is cross-sectional study on them. Cross-sectional study is the study which occur in present moment. Suppose I ask all of you, how many of you use Tinder or Happen dating app? And suppose 10 people out of 100 said, yes, I am using it. So I know about the prevalence of using Tinder. Prevalence means old plus new case right now. Maybe you are using Tinder in your phone for last 3-4 years. Maybe in the morning you came in the mood and downloaded it. So it should be total case, present moment. Right now, how many have Tinder app in the phone? That are the prevalence. And how I came to know the prevalence? By asking questions from everyone. So this is cross-sectional study. And that is why cross-sectional study is known as a snapshot study. Can you take a picture in past or future? Of course not. You can take a picture only in the present moment. So cross-sectional study is a snapshot because we only detect about present moment prevalence. Okay. In future, we go and do cohort study. In past, we collect data by doing case control. In present moment, we do cross-sectional study. Okay. And you can call cross-sectional study as Buddha study. Just like Buddha used to tell us to be in the present moment. cross section is telling us at the present moment. Okay, like if I want to know how many of you have refractive error, I will just take a snapshot right now, and I will know the prevalence of refractive error. How many are wearing glasses? That much may be the case of refractive error. And let's say 50 out of 100 came with refractive error. I know the prevalence right now by doing this snapshot study, cross-sectional study. Okay, so we are doing the same cross-sectional study again and again. This is multi-phase. Let me give you one more example. Suppose you want to know that how many people who are coming positive for general anesthesia actually have the symptoms and all those things. So you can do tuberculin on 1,000 people. Out of 1,000, 400 came positive. On that 400, you do X-ray lung. And out of the 400 whose X-ray lung was done, 100 came positive on X-ray. So you did 100 patient X-ray. And then out of those 100 patients, 80 came positive for general anesthesia. And on that 80 people, suppose you did CBNAT or something else. So this type of study is multi-phase, because first you took a large population, then you keep decreasing small from that. So this is multi-phase random sampling. Okay, so I hope this is clear. Now random sampling is done. Let's revise the random sampling, and I expect you to answer me. Tell me, if I choose people after dividing them into different group of boy girl, I choose 5 from boy, 5 from girl, which sampling? If I choose 5 from boy, 5 from girl, that means it is simple random sampling. No, stratified random sampling, because I am dividing you, then choosing you 5 boy, 5 girl is stratified random. If I just choose 10 people by lottery method, that is simple random sampling. Okay, and if I choose every third student, let's say, so every third I am following a system, that is systematic random sampling. Okay, and if I choose, let's say, 5 students of I'm doing MBBS from Gujarat, 5 students from Bihar, 5 from Nepal, 5 from Bangladesh. So if I'm choosing 5 from different states, this is cluster random sampling. Okay, and then I did multiple cluster sampling, like from the big map, small is taken, that is multi-stage random sampling. And then if you do some cross-section study on a large population and then keep reducing the sample size, that is multi-phase. So remember, map will be given in multi-stage. And that Delhi student marijuana study was multi-stage. And then multi-phase, we keep decreasing the things. Now, after knowing about all the 6 random sampling, let's read 3 simple non-random sampling. One is convenience sampling. So what is convenience sampling? जैसे मेरी मर्जी वैसे करूंगा सैम्पलिंग. सैम्पलिंग एज पर माई विश, एज पर माई मूड, as per my ease, comfort. Like for example, suppose Dr. Avinash is Avinash, which branch you want to take? Suppose Dr. Avinash become a dermatologist, and he is doing a study on psoriasis. And now Dr. Avinash is sitting in the OPD of derma and saying that first 100 patient with psoriasis coming to OPD of derma, of course, will be taken in study. So how this sampling is occurring? This sampling is occurring according to convenience of the dermatologist, Dr. Avinash. He's sitting, patient are coming, and they are getting enrolled in it directly. So this is convenience. Okay. And all of you who will take clinical branch, most of you in your PG, you will do the study, and the study will be done by convenience sampling only, because you have not taken PSM. You cannot roam around and do study among villagers. So mostly clinicians do convenience sampling. But suppose when Avinash was doing this sampling, he came to know that females patient are coming less, male are coming more in my study. So he can put a quota, he can put some condition before doing the study, that in my study only 50 males and 50 females will be taken. These 50 males and 50 female are pre-decided to be taken in the study. Dr. Avinash has pre-decided to take this in the study. So what Dr. Avinash has done, Avinash has put a strata, a layer, that out of 150 will be male, 50 will be female. He is still doing convenience sampling, but he is doing it after dividing them into two groups. That's why quota sampling is known as stratified convenience sampling. He is sitting in OPD, doing it easily, but after dividing. And what Dr. Avinash has done, he put a quota that 50 should be male, 50 should be female. So quota sampling is stratified convenience sampling. Okay. Now, tell me one thing. Have you seen that children who do the work of rag picking, kachda binne wale bacche, they have some cloth in their hand while they are picking the rag and they sniff from it in between. Have you seen this pattern? Have you seen these children sniffing? If you have seen this, it means you are focusing on those children also who are neglected by the society. Good work. You should focus. What do they sniff? They sniff sulochan. And it's a glue to repair puncture of truck tire. They call it solution. There's a very good video on YouTube of Kamlesh and a high guy giving interview on why he sniff sulochan and all those things. Very interesting. Go through it. 5-minute interview only. So that when I was working in this butterfly NGO under Dr. Rita Panikar ma'am, one work which was given in my last 2-3 months of duty is that help them in quitting this habit of sniffing. Because why they sniff it? On sniffing, actually this glue is sulochan, but they call it solution because this is solution to our own problem. When we sniff it, then we don't feel any insult, no pain, no hunger, and we keep doing the work of rag picking. And so if you are seeing any rag picker, you think his age is 10 year, he must be 15, 14 year, 16 year old. When they sniff it, they don't eat food much and therefore they don't grow. Plus, I think this inhalant is neurodegenerative also. So it keeps them at the same stage. So I had one child, his name was Akash, he was in Chandni Chowk slum area. He first came to me and said, ki, Bhaiya, I want to quit this habit. So I said, okay. I took him to 𝐻𝐺𝐴𝐵AD De-Addiction Center of AIIMS. And while coming back, I asked from Akash that, is there any more friend who want to quit? He gave me name of 3 more friends. And next time, all 6 of us was coming together to 𝐻𝐺𝐴𝐵AD De-Addiction Center of AIIMS. One Akash, 3 new friend, one me, one driver. Hai all 6 of us, we became very good friend while going on the way. That doesn't mean that we sniff together. Hai although that children were asking me, ki, Bhaiya, kya chudaoge aap? Jab aapne maja liya hi nahi, when you don't know what is the kick, how will you make us quit? I said, bro, I am not taking it because if I will take it, I may start liking it. And if I start liking it, we will be picking the rag together. This is the answer which you can give to anyone who is offering drug to you. I'm not doing it because I may start liking it. And if I liked it, my life will be destroyed. So say no to drug by saying this cool line. I'm not taking it because I might like it. Now, that 4 students who were with me on that day, 4 children, they give me name of 5 more people. So what is happening in this story? Just like a drop of snow, it starts falling from the mountain, and by the time it reaches the baseline, it becomes a big snowball. Same thing is happening here. We started with 1 child, and that 1 child keep on adding more and more people, and we got 23 children at the end, big sample size. So they ask 2 questions from here. First question is that in which of the following sampling we can add participant after starting the study? So in a snowball sampling, remember, we can continuously add participant. While doing a study also, we can add participant. Okay. Second question they ask, which sampling is done if you are doing a study on, let's say you are doing a study on HIV patient, study on MSM patient, study on intravenous drug use patient, study on inhalant intoxication. This example which I gave, sniffing sulochan, this is inhalant intoxication. Previously, they used to sniff the thinner of the whitener of which we use now, but now whitener is very costly, and shopkeeper who are selling copies and book, they used to say no to them. So then they moved to easier option, sulochan, the glue. That is inhalant. What is IDU? Intravenous drug use. Okay. And what is MSM? MSM means आदमी हूं आदमी से प्यार करता हूं, बस यही गुनाह मैं बार बार करता हूं, आदमी हूं आदमी से प्यार करता हूं, male having sex with male. So you understand, if I want to do a study on MSM or any disease which is hidden in society, I cannot do a study on them without snowball sampling, because they are hidden in the society. So how will I know about the people when I do a snowball sampling? Like for example, if I want to do a study on MSM, male having sex with male, first I will ask some male who have affair with other male, then I will go to their beloved partners and I will ask about their affair, and thus without falling into their trap, I keep on increasing my sample size. This is snowball sampling for hidden. And don't laugh, it's not easy to do a study on MSM. We had one senior who was very tough and all strong male. He did 2-year study on MSM. After doing 2-year study on MSM, whenever he used to talk like this. Kaise ho Ashwani? How are you, Ashwani? I said, I am okay, but why are you touching this? He said, it occurs naturally. And I said, bro, you are naturally giving different vibes. Huh? So this all hidden disease we do snowball. So that's all. This is the 3 type of sampling. One is the convenience, you are sitting in OPD doing it. Other is quota, you are dividing the people and then sitting in OPD doing it. And last is snowball. 3 are non-random sampling. Okay, chalo. Now let's do some question on these topics. And whenever a big question like this come, my advice is directly read the last line. Most of the time in the last line the answers come. Question is, which of the following is not a random sampling method? So which is not a random sampling? Can you give answer? Not a random. Yes, what is your answer? Yes, quota, convenience and snowball. All are non-random sampling. So these are not random. These are non-random. 3 non-random. Second question, that again, big question, read the last line. Which of the following are an example of a non-random sampling? This time they can ask non-random, random classification. Non-random can be quota or convenience or snowball. These are non-random. Chalo. Quota, snowball or convenience. All 3 are given. So answer is all of these. So you see, in this question I was about to do the mistake which students usually do. In the question they find first answer correct, they tick it like I did, without looking that last option is all the above. So when you find the first option correct, do not forget to look that whether all of the above is given in option or not. Okay. Now again big question. So let's read the last one. Every participant has equal chance of selection. So which type of study is there? If everyone has equal chance, this is simple random sampling, best, because it is done by lottery method. So everyone has equal chance. Now, if best sampling for homogeneous population. Homogeneous means which are similar to each other. Like all of you are similar as per your marks or how many movie you watch, you are similar. So when it is homogeneous, it is simple random. And when it is heterogeneous is stratified. But they are not asking heterogeneous in this question. They are asking that we are selecting every nth participant, every third, every fourth. So whenever you choose every third, fourth, what is that? You are following a system and random, systematic random sampling. Okay, systematic sampling. Then if they ask for heterogeneous population, heterogeneous means different, like boy and girl, I am dividing and choosing 5 from them. So for heterogeneous, best is stratified random sampling. Okay, this is for heterogeneous. And then let's do this question. This is a bigger question. Let's understand it. They are asking what is design effect. Simple. Last line, if you read, your time will be very much saved. What is design effect? Design effect is telling us that sample size for cluster random sampling is always lower. No. Cluster people are similar, so their sample size need to be greater. And a cluster random sampling is same is also wrong, lower is also wrong, always greater. Yes, this is the correct option. What is design effect? Design effect means when we choose cluster random sampling, we are choosing cluster random sampling 210 people. When we did simple random sampling, we can do it by 140 people. So sample size for cluster is greater than sample size for simple random sampling. By how much? By design effect. Okay, we already discussed it in detail in Hindi, English both. So I hope you will able to understand this. Sample size for cluster is more, simple random is less. By how much it is more? It is more by design effect. Like here the design effect will come 1.5. 1.5. Now I solved it already. Chalo, next question. A cross-sectional study. Achha, let's again read the last one. Which of the following study compromises of multiple cross-sectional study on same population? This is the question which you need to give answer. Multiple cross-sectional on same population. Is it multi-stage or multi-phase? Answer is yes. What is the answer? Multi-stage, multi-phase. Which one is multiple cross-sectional study? Multiple cross-sectional study is, yes, you all are right, multi-phase. Multi-phase, like the Dr. Krishna study, 20,000 Russian were asked to touch, and then 47 had echo done, and then 3 came with mitral valve prolapse. That is multi-phase. And a multi-stage was Delhi model, and then from a small choosing. So it was multi-phase where multiple cross-sectional study is done. Okay, so next question. This time they are asking which of the following is done according to the researchers. So they have not given any hint in the last line. We need to read the full line. Sampling is a process methodology used sample from a larger population. Which of the following sampling method is done according to the will of researcher? Again, in the last line, hint was hidden. Which one is done according to will, according to ease, according to mood of researcher? That is convenience sampling. Because in convenience sampling, clinicians sit in OPD and the first 100 patients coming are chosen. So which is done according to will, ease or happiness of the researcher? That is convenience sampling. Okay. Then stratified convenience sampling. What is the other name of stratified convenience? In convenience, we are dividing them into 50 male, 50 female, and then choosing that first 50 male, female will be taken in the study. This is quota sampling. So stratified convenience is quota. Now, again, study on people living with HIV, inhalant intoxication, study done on people with hidden disease, that is snowball sampling. Okay. Now, they had given an image here and they asked what is happening in this question. They have some students sitting in the class. Suppose there are 12 students. They choose 5 and 6 sitting together, 11 and 12 sitting together. So these are 6 cluster of students sitting in 6 blocks. And after dividing them into 6 blocks, they choose any 2 blocks. So they are choosing 2 blocks. They are not dividing them and choosing equal from both the subgroup. They are dividing them into 6 blocks and choosing 2 blocks. It's like dividing them into 6 cluster and choosing two cluster. Like suppose you want to do that in North India, how many people are supporter of BJP? You want to know, suppose. So if you want to know how many people support BJP or Congress or any party, you can, if you are choosing 10 people from all the states, this is cluster sampling. So rather than choosing 10 from all 6 states in North India, you decided that I will choose 30 people from 2 states. And 30 people from Punjab, 30 people from Jammu Kashmir. So 30 you are choosing from Jammu Kashmir, 30 people from Punjab, and all the people from Punjab and Jammu Kashmir, they are like cluster. They are 2 blocks, 2 cluster. So this is which sampling? This is cluster random sampling. Okay. Now, again, one more image they have given. What they are doing here is, this time they have this 3 subgroup, and how they are choosing is, they are choosing 1 from above, 2 from middle 2, and last from last row. So what they are doing here is dividing the population into 3 subgroup, 1, 2, and 3, and choosing one sub people from upper and lower, 10 and 5 they have chosen, and 2 people from in between. Maybe the color is a bit same. In the original picture, the color was red and pink. So what they are doing here is they are dividing them into 4 subgroup and choosing 1 from each. So if they are choosing 1 that is a stratified random sampling. So let me explain the difference. In cluster, they choose the whole block. In stratified, they choose equal from every block. So if they are choosing one from every 4 block, that is stratified random sampling. This is stratified random sampling. Okay, chalo. Next question is, let's read the last line. No, last line is not giving any. They are asking some statistical method. So let's read it. A statistical test provides a mechanism for making quantitative decision about a process, and the intent is to determine whether there is enough evidence to reject a hypothesis about the process. The statistical method, which can go further than merely summarizing the data, are a part of which of the following. They are not just summarizing data. Summarizing data is done by mean median mode. When we do mean median mode, we come to know what is in the center of the data, what is the central tendency. डेटा के बीच में क्या है वो पता चलता है मीन मीडियन मोड से, उससे डेटा की समरी पता चल जाती है. जैसे मैं बोल दूं, suppose I am saying that in your class the average weight is 50 kg. So average means mean weight is 50 kg. If I told 50 kg is the average weight of the whole class, then I am summarizing the data of the whole class, that in the class people are around 50 kg. So mean median mode can summarize the data, but they are just summarizing the data into just a data form. So this is descriptive statistics, where you summarize them, where you summarize the data only. But they are asking the question which can go further than just summarizing the data. You don't just summarize data, you also find out meaning out of it, like whether null hypothesis accepted or rejected. This is known as theoretical statistics. Theoretical statistics is p-value, alpha, beta error, null hypothesis acceptance, rejection. That is theoretical statistics. Descriptive statistics, when you are describing data, example is mean median mode, and then measure of dispersion. 5 things tell about dispersion. One is mean deviation, other is range. This question also help you to know the classification of data. These 3 are telling about central tendency. Mean median mode are telling about central tendency, what is in the center of data. And mean deviation, range, standard deviation, standard error, and variance. These 5 things tell about dispersion of data. They tell dispersion of data. Dispersion का मतलब डेटा कितना फैला हुआ है, how much spread is the data, that is dispersion of data. And tell me which type of data you like. कैसा डेटा पसंद है, कैसा रायता पसंद है, फैला हुआ या कटोरी वाला. Which type of data you like, spread one or to the point. Which type of curd do you like, spread one or in a katori? Of course you like the data which is to the point in the katori, because if the curd is spread, how will you eat it? Very difficult now. So similarly, we want curd or raita or data which is to the point, less dispersion. So we find dispersion by these 5 things: mean deviation, range, standard deviation, standard error, variance. We find the central data by mean median mode, central tendency. Then what is inferential statistics? Example of inferential statistics is confidence interval and standard error. Inferential statistics means collecting data from sample and applying it on the whole population. Like if I want to know how many movies you watch in a week, I need not to ask it from everyone. I can just take any 3 students. I will ask how many movies you watch. Suppose they gave I watch 3 plus minus 2 movie. This is the answer came from interviewing 3 students of the class. So I will come in the class and I will say, because these 3 students are taken randomly from the class, the whole class watch 1 to 5 movie. Because it is 3 plus minus 2. 3 plus minus 2 means 1 to 5 movie. I will say that 95% student in the class are watching 1 to 5 movie per week. And this I will tell about 95% students. So this is my 95% confidence interval. What I am doing is, I am asking 3 students that, sorry, very sorry. I am just taking 3 students from the class. I am asking them how many movies you watch in a week. Those sample of 3 students are saying we watch 1 to 5 movie. And then I will come in the class and say that 95% confidence interval of watching movie in this class is 1 to 5. 95% student watch 1 to 5 movie. I am collecting the data from sample, applying it on the whole population. Why I use 95%? Because if I say 99% watch 1 to 5 movie, some of you say, hey, you are underestimating us. We are watching 10 movie. So when I say 99%, no one will trust on that data. And if I say 68% the student watch 1 to 5 movies, 68% no one want to know about. They want to know about the whole class. So we cannot use 68, we cannot use 99. So we commonly use 95% confidence interval. So what is happening in confidence interval? I am collecting data from sample, applying it on the population. This is inferential statistics. Matlab lagana. Just for example, let me give a very good example. Nikhil, come here. Nikhil is collecting the hair first. Suppose I asked Nikhil to come here, and after Nikhil came here, I started touching him like this and opening his button and touching him like this. So when I touch Nikhil like this, you will say कि अबे gay है ये मोटा है ना, this you will say you will guess about my whole life just with my one touch. निखिल कैसा लग रहा था? बहुत घिनौना लग रहा था बोल रहा है यहाँ से. So what I am trying to say you is कि I touch him one time and you guessed about my whole life that I am gay. This is inferential. A small behavior, big application. Similarly, confidence interval is used to collect data from sample and apply it on the whole population. A small action, big implication, big application of that data on big population. So that's his inferential example is confidence interval and standard error. Okay, so I hope you will remember this different type of statistics. Chalo, now this question has came already in INI-CET only, that confidence interval is example of which statistics? Inferential statistics. Okay. Next question is that, let's read the last line. A researcher select all possible sample from a population and plotted the mean of each sample of linear graph. So if you are taking mean of each sample and you are plotting them on a linear graph, which type of data is coming? Then we call it sampling distribution. Sampling distribution means, like, suppose I want to know that how many affairs you had in each year of MBBS. So I took 50 students interview. 50 students were from first year. I asked how many affairs you had in this 1 year. And suppose in first year the answer came, we had 2 affairs for each student. Then I will ask the question for second year 50 student. Then I will ask it for third year. Then I will ask it for fourth year. And then I will ask it for fifth year. 50 student from each year. 50 student from each 1, 2, 3, 4 year. And they will give me some average that in the first year, suppose they gave 2 affairs per year. Here they gave 1 affair per year, 1 affair per year. And in fourth year, you were about to separate, so you propose more. So you said, let's say 3 affairs in the year. So what is the average coming? 2113. I will take this mean of each sample. This average is mean. So I will take mean of each sample 2113 and I can plot a linear diagram from it. And like this, that 2, then 1, 1 and then 3. This type of affair occur in MBBS. First year, then second year and third year, and this 2 can be second and third year, third year, and then this one 3 affair, fourth year. So I will see this is number of affairs. Which type of affair? Mean affair. Average number of affair. Average number of affair is known as mean affair. So I am taking mean of sample on linear graph. We call it sampling distribution. And a mean of 4 sample I took, arrange them in linear graph, sampling distribution. Chalo, next question. In the central limit theorem, it states that if the sample is too big, no matter what is the shape of the population distribution, it approaches a normal distribution. The central limit theorem is relatable to which among the following? So, what is this question? Let me explain. They are saying that suppose I took weight or height. Suppose I took height of 2000 students who are studying in Gautam Nagar near in Delhi. And I measure height of 2000 students This is a big sample size. And whenever the sample size get larger, like here, the sample size is 200, sample size is very large. If the sample size is large, data is always normal, because some student will have, let's say, 30 centimeter, 140 centimeter height. Some student will have 180, 190 centimeter height. Most of us will be between 140 to 170. So 140 to 170 is the normal thing. And you can see when we do collection of data on 2000 people, data become normal. If I did height measurement of only 20 people, it may be that all 20 people are very less tall or all 20 people are very tall. So this type of data is skewed data. This is positive skewed because it's towards our right hand side, so it's positive skewed data. And this is negative skewed curve because it's towards our left hand side. And this is normal curve. So whenever I collect data from 2000 people, big sample size, data always come normal. This is known as central limit theorem. If you did data collection on large sample, then in a large sample, the distribution is always normal. Okay, because if you remove some people also, it doesn't matter. If the 2000 sample size is there, data will remain normal. So this is known as central limit theorem. Now the question is, central limit theorem is relatable to which of the following? This central limit theorem is just random sampling distribution. When the sample is chosen randomly in the student group, I choose any 2000, then some will have less height, some will have more, some will have, most will have middle level of height. So when I choose randomly people, this type of data come. So this normal distribution is coming because we are choosing people randomly from the whole Gautam Nagar. Whenever I choose random people, there is a chance that if the sample size is, if I choose random people, there is always this clarity that in randomly chosen large sample size, data will be normal. Okay? जब भी हम 2000 लोगों को किसी भी स्टडी के लिए रैंडमली चूज किए, तो इतना बड़ा सैंपल साइज है, कुछ लोगों का कम, कुछ लोगों का ज्यादा, बाकी मोस्टली लोगों का बीच में आंसर आएगा और डेटा नॉर्मल हो जाएगा. इसको हम कहते हैं रैंडम सैम्पलिंग डिस्ट्रीब्यूशन. हम लोग जब रैंडमली चूज करते हैं तो डेटा हमेशा नॉर्मल आता है, बड़े सैंपल साइज का डेटा हमेशा नॉर्मल आता है. व्हाट आई वाज सेइंग इन हिंदी वाज, whenever we choose randomly 2000 people or 4000 people, big sample size from any population, due to randomness, the data always come in normal curve. So that is always normal curve. This is known as central limit theorem. So central limit theorem is talking about random sampling distribution. Skewness of distribution comes when the sample size is small. Skewness of distribution is at less sample size or smaller sample size give us skewness of distribution. Graphical representation of nominal data is just like histogram and all. And this nominal data is like boy, girl. And so if I'm doing graphical representation of boys and girls who are attending my class, maybe suppose boys come like this and girls came like this. What is the percentage of a student? How many are boys? How many are girls? This is nominal data. Boy, girl, male, female, anemic, non-anemic. This can be nominal. Nominal means yes, no type of data. This is also dichotomous. And two group. Nominal simply means which cannot be arranged in order, like your caste, your color, your religion. This is just name. You cannot arrange them. So nominal data diagram comes like this, not a bell-shaped curve, not a normal distribution. And a statistical test between two group and is like chi-square, paired, unpaired. They are a statistical test. And we are not talking about test. We are talking about that when we represent data like this normal data, how is it coming? So it is coming due to random sampling distribution. Okay. Chalo. Next question is, this time they are saying that standard deviation is a measure of the amount of dispersion. We discussed now that a standard deviation tell how much the data is spread, and we want a data which is less spread, to the point. So if the standard deviation is low, that means value tend to be closer to the mean, and high standard deviation means value are spread out over a wider range. Standard deviation of mean, major variation caused by which among the following? So standard deviation, this is measuring the deviation variation which is due to which of the following? Very good question. If you can answer this question, I will be really happy. And this point is they are asking is that suppose I am collecting hemoglobin of 100 girls. So if I took hemoglobin of 100 girls, data can come something like this. Starting from 8, it can go till, let's say, 30. This is when I did it on sample size of 100 students. Now, if I did hemoglobin measurement of only 10 students, or if I did sample size observation of, let's say, 1000 students, and their hemoglobin I measured. So if I am measuring 1000 student hemoglobin, the graph will come something like this. It will be like this. It will become more to the point when I did it on 1000 people. It is still normal, but this normal become precise. You can see most of the student will come between 9 to 11. You can check your batchmates. Their score is 9 to 11. When our data become to the point, when our sample size is increased, this is simple thing. It is just telling us that if sample size is more, then our data is to the point precise. Precision become more. Sample size is more, the data become to the point precise. Like for example, if you want to know, before going into live-in relationship with my girlfriend for 4 years, and then she liked the same boy, so we married also. So before going in the live-in relationship, I was used to pick up my girl, my better half, from the girls' hostel, and she used to call me to come at 8 p.m. usually. Whenever I used to go at 8 p.m., she used to come at 8:20, 8:25 and all. So after observing her for 10 times, let's say, I started coming at 8:20, and then 8:25, usually she used to come between 20 and 25. I used to pick up and come back. So when you observe more and more observation means more sample size. Then you will know that this is the precise time when someone will come. This is the precise answer which will come. So when I pick up her again and again on different day, then my time limit, earlier it was 8 to 8:30. Then my time become less and become 8:20 to 8:30, and I started coming like that. So when my data become more precise, when I observed her again and again. So this is what they are saying, that if, and this is the relationship with the standard deviation. If the sample size is 100, standard deviation is more, suppose standard deviation is 2. If the sample size is 2000 only, standard deviation become less, it can become something like 1. So bigger sample size, data is to the point, less dispersed. And this, they are asking the question, ki standard deviation of mean variation caused by which of the following? This fluctuation which is coming by choosing large sample, we are reducing our error. This is which error? So this is known as random error. Random error is something which occur due to small sample size. So if you increase sample size, random error will go away. Let me explain this with a very good example. Suppose my friend Dr. Lone Bilal is taken MD medicine, and after this he is doing DM in cardiology, and he got too much into study, and now he is sitting in OPD, and an Ammaji came of 55-year-old. She take her systolic BP and it came 160. She asked the Ammaji to rest for 10 minutes, and then again Dr. Lone Bilal measured the systolic BP and it came, suppose, 165. Now what will you do, Dr. Lone Bilal? And a good name. What will you write in the OPD card? Will you write 160 or 165? Because after resting, if it become less, then we write the less one. But here it has increased. What will you write? Or will you take BP one more time and then write the average of 3? This is the better answer. you measure it 3 times and write the average, that is there. But suppose there one more doctor like me is sitting there, doctor of PSM, who has no work in the world. I measured the BP of Amma ji 10 times and then write the average. And I also learned that her daughter-in-law is not listening to her. I talked with her and no work, so I took BP 10 times and average. Whose answer will be more accurate? 3 times average or 10 times average? You understand? When I took 10 times and do the average, then the data become more precise. When I increase the sample size 10 times, my data become more precise. If the sample size is less, only 2 times, 3 times BP measured, then data is more spread. 10 times and average data become to the point. So, if you collect data again and again, this type of random fluctuation become less. This is which error occurring? 160, 165 data. This is random error, natural mistake, galti se bhool chuk. Small error by natural mistake is known as random error. Like one time the cuff is a little bit loose, it came 160. Cuff become tight, it become 165. So these are small random error. Why random error occur? Because you have taken measurement only 2-3 times. Due to small sample size, random error is happening. If you take BP 10 times and took average, then random error will go away. So that is what they are asking, that if we are measuring a standard deviation and standard deviation is coming big, it means a small sample size. Standard deviation is coming small to the point, it means sample size is bigger. So if we are increasing sample size and we are reducing this fluctuation in data, which error we are reducing, which error we are removing? We are removing random error. इनका कहना यह है कि सैंपल साइज बड़ा करने से डेटा टू द पॉइंट हो जाता है. तो सैंपल साइज बड़ा करके हम डेटा को बेटर कर रहे हैं और कौन से एरर को निकाल के हटा रहे हैं? तो हम रैंडम एरर को निकाल के बाहर कर रहे हैं. क्योंकि रैंडम एरर क्यों होता है? जब कभी भी आप बीपी 2-3 बार लोगे तो उसमें कुछ गलती हो सकती है. अगर बीपी 10 टाइम लेके एवरेज ले लोगे तो गलती गायब हो जाएगी. सैंपल साइज बढ़ाने से रैंडम एरर खत्म हो जाता है. If you increase sample size, random error goes away. So by increasing sample size, data is becoming precise, standard deviation is coming less. It is which error is removing by increasing sample size? Random error removed by increasing sample size. Which error do not remove by increasing sample size? Systematic error. Let me give you one more example. Suppose this time I am taking BP of Lone Bilal again with a different BP machine. And one time I took BP, it came, suppose her BP, Lone Bilal BP came 184. Second time I took his BP, it again came 184. Third time I took it, it again came 184. So if the BP is coming again and again 184, what is the reason? Is Lone Bilal seen something which has increased his BP? Even if Dr. Lone Bilal will see everything, BP will not go till 184, right? It will go till 140, 150. So why this BP is coming? क्योंकि मशीन खराब है. डॉक्टर लोन बिलाल की नहीं, बीपी की मशीन खराब है ना. Here the machine is not functioning well and it's not the machine of Dr. Lone Bilal, it's the machine, BP machine, which is not functioning well. So the result is coming 184, 184, 84. This is an example of systematic error, and systematic error is known as bias. This time, if I took BP even 200 times with this wrong machine, will that error will go away? 2000 बार भी बीपी ले लो, आंसर गलत ही आएगा क्योंकि मशीन ही खराब है. So even if I took it 2000 times, BP will come wrong because the machine is faulty. This means by increasing sample size, systematic error is not getting affected. Bias do not get affected by increasing sample size, but when you increase sample size, random error goes away. Okay, so which error goes away by increasing sample size? Random error. Which, if the standard deviation is coming less, we are removing standard error. रैंडम एरर बाय इंक्रीजिंग सैंपल साइज. सैंपल साइज बढ़ाएंगे तो रैंडम एरर कम होगा. सैंपल साइज कितने बार भी बीपी ले लो, मशीन खराब हो तो जो गलत आ रहा है वो गलत ही आएगा. सिस्टमैटिक एरर will remain like that even if you increase sample size, but random error decrease when you increase sample size. Okay, chalo, next question is that sampling is this time, which of the following is true about simple random sampling? They are just asking which is correct for simple random. Sampling method of choice for heterogeneous population? No, this is a stratified random. Member are selected without specifying any criteria of selection, it can be there. Picking 5th or 10th, this is which sampling? 5th or 10th? Systematic random, है ना? Population is randomly divided into two clusters. This is cluster random. But if you are selecting without any criteria, that is simple random. For example, in my MD from AIIMS New Delhi, my guide gave me a study on organ donation. That people in rural parts of Haryana, do they want to donate organ or not? Why? What we can do to increase it, organ donation and all. So in my village PHC, there were 28 villages and 46,000 people were living in that Dayalpur PHC areas. And it has some part of Chhesa PHC also in my study. So from those 46,000 people, I need to interview 1,000 people. And because all 46,000 people, I thought they all are villager, they all are homogeneous, they all are simple, same to each other. Because I thought all the villager are same, so I did not put any criteria before their selection. I just put 48,000 name in the computer and I gave the command on SPSS software, give me any 1050 name. So by lottery method, it gave me 1050 name. This is simple random sampling. Why I did this? Because I had no criteria before selection and everyone was same, everyone was homogeneous, everyone was same villager. So I did simple random. Okay. So whenever it is homogeneous, we do simple random. But there is one problem in my study. This is a very good example which can clarify your concept also. The problem was, one question was, does religion promote organ donation or not? And in my AIIMS New Delhi population where I was doing this study, only 2% population was Muslim. 2% of 1000 is 20. And I cannot say whether Islam promote organ donation or not based on interview of 20 people. I need more people to comment on religion. So actually my simple random sampling which I did was not able to answer this question that whether religion promote organ donation or not. So what I should have done, rather than choosing 1,000 people randomly out of 48,000, I should have pre-decided that I will choose 333 people out of 1,000 from Islam religion, 333 out of 1,000 from Hindu religion, and 333 out of 1,000 from Sikh religion, because in that Haryana part Sikh religion was also there. So which sampling I am doing here? Is it cluster or stratified? Choosing 333 from Islam, 333 from Hindu, 333 from Sikh. Is it cluster random or stratified random? This is a division which I have created. They are living together in Haryana. I am dividing them into religion. Their origin is actually they are living together and I am dividing them. So whenever you divide them, even if they are living together, that is stratified. So rather than doing simple random, I should have divided them 333, 333, 333. After dividing, it becomes stratified because I'm dividing them based on religion. And then I should have asked them, does religion promote organ donation or not? So then my study could have answered the question based on religion. Because based on religion, people are heterogeneous, different. Based on just being villager, no criteria, they are simple. They are homogeneous. So then we do simple random sampling. So we do simple random sampling when there is no criteria. And if there is criteria, like choosing equal number from different religion, it's stratified. Okay, chalo. In statistics, cluster sampling is a sampling plan used when mutually homogeneous yet internally heterogeneous groups being asked evident in a statistical population. All of the following are true about cluster sampling except cluster are created based on similarities. No, I don't think this is the correct statement. Cluster are created based on common origin. It is a two-stage sampling, cheaper than most other method. It is a method used for rapid assessment. Yes, it is cheaper because rather than doing random roaming around in the village, in the whole Bihar and asking a question from people, you just choose 7 children from 30 villages and interview their mother. So this will save your time and this will save your money. So cluster random is cheaper and less time taking. This too is correct. And it is two-stage sampling. This is also correct. Because in cluster, we first choosing 30 villages from Bihar. So this is first cluster. Village is a cluster. Then from these 30 villages, I am choosing 7 children. So this is the second time I am choosing cluster. From the village, I am choosing a cluster of 7 children. So first I am choosing 30 villages which are cluster. Then I am choosing 7 children from villages which is also cluster. So I'm doing cluster random in 2 stage. So all 3 are correct. But clusters are not created based on similarity. Based on similarity, if you are dividing them, that is stratified random sampling. Like based on boys and girls sex, you are dividing them. So correct answer will be this is not correct, except they have asked which one is not correct. This one is not correct. Cluster are not created based on similarity. Cluster have common origin. Like they all 7 children are coming from same village, so they have common origin. That is cluster. Not we are not creating them. They are already having common origin. Okay. Again, the question came that if we are doing immunization study, which sampling is done? WHO immunization study, cluster random sampling. So what we are doing, cluster random sampling. Okay. So you can see from a larger population, we choose yes. So we are doing cluster random when we are choosing 7 children from 30 villages, and cluster random sampling is done to know the immunization status. Okay. But if they ask, why I was reading the whole question, because if they ask the question in a different way, that data of immunization come from which study? Data of immunization in India, that how many children are immunized? Data of immunization from all over India come from which study? So the study is NFHS DLHS. NFHS DLHS give us immunization data about the whole country. They don't compare 2 parts, they just collect data from the whole part. And how NFHS DLHS done? They are done by multi-stage random sampling. So if they ask how the data of immunization is collected from India, it is collected by multi-stage random sampling. But if they ask that when we have to know that how much children are immunized in each different area, then which sampling we do? Cluster sampling. If you want to compare Bihar and UP based on immunization, then you do cluster sampling, WHO immunization study. But if they ask the data that how many children in Bihar are immunized, if you want to know that, then you have to collect the data by multi-stage random sampling. From the Bihar, you will choose some 1, 2, 3 state district. Then from the district, you will choose village. From the village, you will choose some mothers, and then you will interview the mother and say the data for the whole Bihar. So when you want to collect the data for whole Bihar, you do multi-stage random sampling, which is multiple cluster sampling. And if you want to compare Bihar and UP, then you do WHO immunization study by cluster sampling. Okay, I hope it is clear. If not, I have given you my number and made Telegram group address, so you can always ask it question there. Now, if it is not clear, you can post it on my YouTube comment box also right now, and I will answer your question for sure. Chalo, now there is a question by Dr. Lone Bilal. If a question mentions sampling easily available or readily accessible subject, it is like referring to convenience sampling. Yes. If they say patient who are coming to OPD, readily accessible patient, this is convenience sampling. Correct, Dr. Lone Bilal, you are correct. Dr. DK is asking me to take an image-based session for FMG student. Of course. In this next month, within first 1 week of May, I will take an image-based session for FMG students separately. Whatever you wish, your wish is my command. If you want to tell me that teach this thing, I will teach that. Like sampling technique, I am teaching based off one of the student requests that, sir, in NEET last year 2 question came and INI-CET question are expected, FMG question are expected from sampling technique. So I am teaching it. Okay. So whatever you ask, I will definitely do it. My favorite cartoon character is Genie, and your wish is my command. Okay. So keep saying it, no problem. Research is conducted to know the nutritional status of children in particular district. For this purpose, 2 children are randomly selected from every school in the district. So what they are doing? They choose district from the district, state from the state, they choose district from the district, they choose 2 schools. So from one big, they are choosing a small thing. So what they are doing here? They are doing multiple cluster sampling. So you can, out of the 4, you can choose cluster. And this is actually, if you are from a big state, you are choosing district, and from district, you are choosing some school. This is the correct answer will be multiple cluster sampling. And the other name of multiple cluster sampling is multi-stage random sampling. But if multi-stage random sampling is not given in the option, then because in multi-stage we do multiple cluster, and this is multiple cluster sampling only, so the second best option we can choose is cluster. From the district I choose some school, from the school I will do the survey and tell it for the whole state. So this is multiple stage sampling or multiple cluster sampling, so you can call it multi-cluster, okay, cluster sampling. Then design effect, if they ask question on design effect deal with cluster sampling, so answer become cluster sampling, okay. And what is design effect? We have read sample size of cluster is always bigger than sample size of simple random. Now they are again creating a question that sample are used in statistical testing when population sizes are too large for the test to include all the possible participant or observation, and as which does not reflect any bias towards a specific attribute. In a study, first school are sampled, then section, and finally student. You are choosing school, then section, then student. You are doing multi-stage sampling. Big, then a small, then a small. You are choosing from state, some district, some village, like that. That is multi-stage. Similarly here, you are choosing school, then section, then each section you are interviewing. This is multi-stage. Okay. Next question. Sampling is a process used in this is just bullshit line in the above part. Let's read the last line. That for a epidemiological study, every 10th person, every nth person you are selecting, that is systematic random sampling. If I am choosing every first and fourth house for an interview on condom use, systematic random. So I am choosing every nth, systematic random. So you have find the keyword and answer. Like if subject are assigned according to the potential factor that will influence the outcome of the study. Can you answer this question? If you are dividing people based on religion, because religion can affect organ donation. So if you are dividing people based on religion or sex, like sex can affect smoking prevalence. So if you are dividing people based on the potential factor that can influence the outcome, it is stratified random sampling. If you are dividing people based on gender, religion, anything which can influence the result of the study, if you are dividing them, that is stratified random sampling. Okay. Chalo. Then more question they are giving that a statist random error in experimental measure are caused by unknown and unprecedented change in the experiment of these changes may occur. Random is random error. They are describing that. Which of the following is not true about random error? So we discussed already that random error is something which is just occurring due to small sample size. Like when you are measuring BP 2 times, then fluctuation can come. If you measure it 10 times and took average, random error will go away. So we have to use the same concept to answer it. Sampling error or random error? It can be random error. It cannot be completely eliminated. This line is definitely correct. Some random error always occur. We can never be 100% correct. So it can not be completely eliminated. This is correct statement, and they are asking not true, which is not true. So answer cannot be B, because B is true. We cannot eliminate random error. Random error can cause bias. No. Bias is one-sided mistake. Bias is the other name of systematic error. So systematic error, it occur when suppose the instrument by which we are collecting data is wrong, measurement is wrong, or when you selected wrong people, or when the data analysis is done wrong. So these three is the reason of systematic error. What are the three reasons of systematic error? Measurement bias, selection bias, or data analysis is wrong. Then bias or systematic error occur. So random error is not causing systematic error. Random error is different thing. Systematic error is different thing. Like, for example, there is this dot with this bullseye, central line. And suppose someone A is throwing the dot, and every time it throws the dot, it hits somewhere close to the target. So this time, the A is doing random error. This is some natural fluctuation which can never be removed. This is random error. And in this case, A, he know how to throw. So he have the accuracy. Validity is high. But you don't know where he will hit. So reliability is low. Because he is not precise. Reliability means precision. You cannot tell where he will hit the next time. But you know he know how to throw. This is reliability. Validity high, reliability is low. Now suppose second time someone is hitting dart in such a way that every time it hit this point only. He make a big hole but in a wrong area. So this time which error is occurring? Here we have systematic error or bias. This time he is wrong one-sided again and again. Why he is like that? Maybe he is bhenga, looking London hitting Tokyo, maybe he is having a squint, or maybe the air is blowing like that, and every time it hit correct, but it hit the side. So this is systematic error and bias. And in the case of second person, he don't know how to throw, maybe his validity is low, but he is definitely reliable, precise, that next time also he will hit the same area. So the second one is having high precision, low validity. Why high precision? Because you know where it will hit. So the bias and random error are totally different thing. Random error is natural fluctuation. Bias is one-sided, again and again wrong answer. So do remember, not true is random error cannot cause bias. It cannot cause bias. It can cause bias is wrong. Okay. Sampling error or sampling error means, suppose you want to choose young people for your study, but like in my organ donation study, I want to include general population for organ donation study. But rather than going around and choosing people from the whole population, I thought, why not let's sit in the Nescafe of AIIMS New Delhi, and whoever will come there drinking coffee, I will take his interview, and if she is a good girl, I will also take her number. So rather than roaming around and doing simple random, I sit in Nescafe and did convenience sampling. So if I did convenience sampling, it is non-random. Why it is non-random? Because now I will only have young people in my study. I will not have old age people. I will have very less married couple. I will have, so my sample is not representation of real population. This is known as sampling error. When you choose the sample which is different than natural population. And sampling error can occur due to random choices also. Like suppose you are choosing sample, and in that sample you randomly got, suppose you want in a class, you want to know how many smoke. So you randomly choose people, and out of 10 you got 9 smokers who were smoking, and the answer came that your smoking is very high in the class because all the 9 people you choose randomly, they were a smoker. So if you are choosing randomly, you can choose wrong sample of smokers. So random error, sampling error, this is correct. Random error cannot be completely eliminated. This is also correct. Some random error will always remain there. And last option, systematic error are different from random error. This is also correct. And I explained how systematic error is bias and random error is different. So which is not correct? Random error can cause bias is not correct because random error is different and bias is systematic error, which is different. Okay. Chalo, very good question. So we have done every question which can come from this topic, more than what can come in this topic. Plus we also read about NFHS, DHS, LHS. We read about census, SRS, sex ratio question numerical in this session. I hope you found this session useful, and this will be useful for your upcoming exam because sampling technique, a lot of questions come again and again in the recent years. If you want to read anything or any question is not there, any question you want to ask, you have my number in the session and you can post it on the Med Telegram group to connect with me. Okay. Keep enjoying your journey of learning and be in the moment, enjoy the flow. And I would request that when you get the PPT PDF of this session, just after this, there will be PDF available in the Telegram groups and all. Try to do this question one more time by yourself without checking out the answer, or listen to the video one more time in 2x, 3x and do the question yourself. Okay, that will help you in revising the topic. Love you all. Hasta la vista. Das vidania. Thank you so much, my friend. Thank you.